right, thank you very much. So I have to say, usually I like to pace when I present. And if there is a hell and I die and go to hell, I am going to be forced to present on a stage this size for eternity. And because this is like the smallest stage ever. And so it's going to be really hard for me not to walk around. And when I stumble off the stage, I called it, right? And so I am an experimental economist. I have been teaching principles of economics and other courses for almost 15 years now, and I have always used in some form experiments in almost all of the courses that I've taught. And what I hope to do today is relate to you the most recent iteration of my use of games, markets, and experiments, in this case, in two very large principal sections of economics. And so, in some ways, we misuse the term experiment when we're talking about running games, markets, and experiments in an economics course. And so basically what I mean is, right, we're going to put, and if you notice, I've been moving the whole time, and I've been like getting too close to the edge, and it's getting scary. And so we're going to put students into a particular economic environment where the economic environment closely matches the environment that we have set up in theory, right? And the students then participate. They make the actual choices, right, where their choices lead to payoffs, where payoffs might just be points. And then potentially, the environment is repeated if learning how to deal and what choices to make in this environment might be important. And then the results are revealed. Classic example, going back to Vernon Smith, probably now well over 50 years ago. In principles, we teach supply and demand, right? And we put the supply curve, we put the demand curve, and then we do a little bit of hand waving. And we say the perfectly competitive market finds this price that equates quantity supplied and quantity demanded. And perhaps we do a little bit more hand waving. We say, imagine the price is high, excess supply, downward pressure, etc. But it still is this leap of faith for many students to sort of say, well, how, you tell me, right, that we're going to find this price. Like, why? Yes, no, why, right? And so by running the actual experiment where some students are buyers, some students are sellers, and values are induced for their value of procuring an item or their cost of giving up an item, right? It's one of the most powerful results that I show is, right, very quickly, right, in conditions that approximate our competitive market model, right, we do, in fact, find the price that equates supply and demand, right? And so that's what the classic experiment that I know a bunch of you have probably run in your classes. And so why run experiments? One reason is because there's evidence that they're effective. And Sam Allgood, in a recent JEL piece, the evidence on the use of classroom experiments shows consistent positive effects on student achievement. Right? And I want to introduce two caveats there. Caveat number one is if I was being honest about interpreting the studies that Sam Allgood is referring to here, I would say that the evidence shows that when experimental economists use classroom experiments, it's really effective. Right? Because traditionally, people who have run experiments in their class, not exclusively, but the people who've run experiments in their class have been experimental economists, like myself, who ran experiments as grad students, and we get our own classes, and we're like, yes, I'm going to run experiments. And then even better, it's like, oh, wait a second, I'm going to experiment on experiments, so now I'm going to publish this paper where I experiment on experiments and show that experiments are effective. Right? And so the literature on human subject or classroom experiments is almost entirely written by experimental economists. And so it's a darn fine, good question whether non-experimental economists will find will find similar results when they try and implement classroom experiments in their course. The next thing, which is really important, Cartwright, another experimental economist, he shows that the strongest effect is when you don't just run experiments and move on, but you actually reflect on what had happened. And so my implementation this past year, right, was I actually implemented experiments in my TA-led tutorials, right? And tutorials at the University of Toronto are similar to tutorials at many other large institutions where the grad student shows up at the tutorial, right? It's supposed to be like a more intimate setting, right? So instead of 500 students, you go to a tutorial with 50 students. I supplied questions in advance. I don't supply the answers because I want my students to have some incentive to show up. The TA shows up at the tutorial, and the students are like ready to write, and the TA does this for 50 minutes. Right? And needless to say, right, it's not a great experience for anyone. Right? And so what I decided to do was I implemented MobLab, which I'm going to discuss in my tutorial. Right? MobLab access is required, and it requires an internet-connected device. And thankfully, in 2017, pretty much all your students are carrying an internet-connected device. So what I did is have MobLab in every tutorial, right? And participation was required. Right? So students are in no way required to attend my lecture, but they're required to attend the tutorial. Right? And we had 19 different tutorials last year. Right? In 9 out of the 19 tutorials, we used MobLab similar to the iClickers that are on all of your table. MobLab has a survey functionality which allows the instructor to pose questions to students and students respond. Right? In 9 out of 19 tutorials, we used MobLab like that. Right? In 15 out of 19 tutorials, right, we had some sort of in-class writing, once again using MobLab. Right? One of the other things is MobLab in their survey things allows for free text responses. Right? And if you forced me to do a writing assignment on my phone, like it would take me forever. But students today, they text really quickly. And it's astounding how much they can write on their phones in like a few minutes. Right? But importantly, right, you'll notice, and then we have games in the majority of micro-tutorials. Right? And for any game that we run, right, there's, as I'm going to show, right, we try and integrate the game with reflection questions, right? What did you just do, right? Why did you do what you just did, right? Try and make this an active participation, right? And traditional tutorial problem solving, right? And so the one thing that you'll notice that I've done, right, is that basically I've made my tutorials almost like a flipped classroom, right? In most of the tutorials, there are clicker-like questions. In almost all of the tutorial, in other tutorials, there was active participation with participating in games, markets, and experiments. We had reflective writing. And I think this is important. I'll discuss this a little bit more later. Right? And so what I'd like to do is I'd like to show you some data from this last year. And the first thing that I'm going to do is I'm going to present evidence, right? That tutorial participation, which in many cases included participation in games, markets, and experiments, led to increased student outcomes. Right? And importantly, I'm going to show that this complements other means of consistent problem solving and engagement. Right? And I think, I just recently have had an opportunity to come up, to write my teaching dossier. Right? And it forces you to reflect on what you've been doing. And one thing that I realize that I'm insanely passionate about is I think it's important for our students to do economics consistently throughout the semester. Right? And I realize that in essence what I've done as an instructor has been to structure my class to try and make sure that all the time they are engaging in economics, that they are solving problems, that they're participating in experiments, et cetera. And I know that many of you do that as well. And I'm going to show how participating in tutorials, many of which had games, markets, and experiments, how that led to improved student outcomes. And then I'm going to briefly discuss 2 experiments that my TAs ran in class. I'm going to do 2 things. First off, I'm going to show the outline of what a tutorial looks like. because I think it's really important to show that, right, I think for tutorials, for experiments to be effective, you can't just do the experiment. You've got to scaffold it, right, with either problem solving or reflection, and I will show what we did. And we will show that, right, for these two experiments which I've analyzed, right, student performance on test questions related to these tutorials, related to these games, markets, and experiments was positive. So my empirical strategy, right, and I hate to do this to you, right, we're going to do a little bit of econometrics. Damn, I hate that, right? But I think it's important. I think it'll at least take away some of the questions that I'm sure to get, right? And basically what I did in my, it turns out in hindsight really smartly, right, was over the course of the year, I allow my students to drop either their lowest participation in tutorial or drop their lowest quiz score. Right? And what this does is it creates some sort of within student variation in terms of when they take these drops. Some students might take their drops before term test 1. Some students might take more drops before term test 2. Right? And then what I am able to do, basically, is look within each subject and see if the number of tutorials that they've missed since the last term test, right, does that affect their performance on this particular term test? Right? Does the number of quizzes that a student didn't take since the last term test, does that affect performance on this term test? Right? And what I find is students have periods where they participate a lot and periods where they participate very or less frequently. And if there's a difference in outcomes between those periods in which they participate a lot and those periods in which they don't participate a lot, right, I can identify, right, the effect of consistent effort in tutorials, consistent effort on quizzes. But importantly, I want to interpret carefully. Right? And so when I do this fixed effects model, the first thing that I find out is that, well, first, percent correct attempted quizzes, unsurprisingly, and I'm sure you all know this, students who do well on quizzes do well on tests. Not a big surprise. Right? What I also find is that actually attempting the quiz, right, when even controlling for the grade on the quiz, a student attempting to solve these problems on a quiz actually improves their performance on the subsequent test, or is correlated with improved performance on a subsequent test. I also, in this same model, right, put in the percent of tutorials attended since the last term test. Right? And I find a significant effect here as well. Right? And so to put this in perspective, right, it is not uncommon for a student's tutorial participation to range from, for example, 75% to 25%. Right? That happened in at least 25% of my students, that they had a swing in tutorial attendance of 50 percentage points. Right? And that swing of going from attending 25% of the tutorials to attending 75% of the tutorials led to a 2.5 increase in the number of marks that they earned on a term test, and this is significant. What is also important to note here is, to some extent, I am measuring, right, just, these are measures of being engaged with the class in general. And there are times in students' lives when, just for whatever reason, they're not engaged with the material, and these are probably the times in their lives that they're not going to go to tutorials, and I agree. But what I also think is important is I've been measuring, in this regression, I measure for 2 different forms of being engaged with the material since the last term test. Have you been taking quizzes? Have you been attending tutorials? Right? And the fact that when I control for one measure of being engaged with the material since last year, quizzes, right, I still am able to find a significant coefficient on tutorials, another way of being engaged. It suggests that I'm not just measuring being engaged, right, that something is actually good happening in my tutorials. Right? So now I want to talk about one, and yeah, maybe just one, because I'm running out of time. So I'll just talk about one game that I ran, that my TAs ran with students. And it's one of my favorite MobLab games. It looks at long-run equilibrium in competitive markets. Right? And we all know the standard entry and exit model that we have, and it leads to a zero profit equilibrium. And I'm sure you've had students who basically have some measure of disbelief. Right? Because at the end of the day, we're saying, yes, there are thousands of companies out there, and all of them can earn zero economic profits. But 97 of them are going to be in the market. Right? And the student's like, which 97? You're like, I don't know. Right? But I know there'll be 97. There won't be 104. There's not going to be 105. There's going to be 97. They're like, but anyone can be. You know, I'm like, yes. Right? There's an infinite number of equilibria, but I know the equilibrium is going to happen. So once again, this is a great example where we present a model, and the students are like, but how do I know that that's what's going to happen? Right? And hopefully by actually participating in this model, it becomes more real to them. So the Mob Drive game, right, is a MobLab game where students participate. They are basically Uber drivers. And they are deciding, or potential Uber drivers. Now, they can't say Uber because they would get sued. Might be good press. You should change it to Uber. It might work out well for you. But each period, each student player chooses whether to incur a fixed cost to drive for Uber. Right? The revenue per hour worked is determined by the number of entrants. If there's lots of Ubers out there, the price is going to be low. Right? If there's very few Ubers out there, the price is going to be high. Importantly, the relationship is known to students. Right? If a student enters the market, if a driver enters the market, they learn how many they then choose how many hours to drive based on the revenue that they get per hour. So this gives a little bit more experience with marginal benefit, marginal cost. And importantly, if they did not enter, they can see, right, well, maybe should I have entered? Would I have been profitable had I not entered? Right, this is the screen. This is one of the MobLab screens. Right? In this case, this is a driver who had entered. There are 5 drivers who have entered. Because 5 drivers have entered, the revenue per hour is here. The student then who has entered then gets to choose the number of hours, and as they change the number of hours, right, the marginal benefit goes up, and then this is a nice graphical representation of do something as long as marginal benefit is at least as large as marginal cost. Right? And so my TAs did this in tutorial. Right? They started out, MobLab has produced some video instructions, right? And this is a very important thing. You want to make sure your students understand, right, what the relationship is between their choices and their payoffs, and doing good experiment instructions, right? As an experimental economist, this is something that I know very well, right? You give really good instructions. MobLab does a good job of providing your students with instructions. In this case, I also did instruction comprehension questions. Do you understand how your profits are generated, right? And then we played the first game. Right? And the equilibrium was 9 entrants out of 12 entrants in each market. And afterwards, we reviewed the results. And I'm not going to show the results because I could pick the results that look the best, and you wouldn't. Yeah. Anyway, in general, right, we do a good job of converging to the equilibrium where 9 out of 12 entrants enter. Right? I then introduced demand shift or my TAs did, by a MobLab survey question. Right? And in this MobLab survey question, I basically say, predict what would happen if there is the introduction of a substitute. And this I can do very easily because Lyft is not yet in Toronto, yet most of my students understand that there are other rideshare services out there. And so I say, imagine another rideshare service, let's call it Lyft, comes into Toronto. What might happen to the demand for Ubered cars, right? How might that affect the revenue per hour of an Uber driver, right? And so at this point, I'm introducing a demand shift where they're doing it themselves, but we're going to play game 2, the equilibrium, where 7 out of 12 in each market enter, right? And so they are living, right, the model in which we present in the textbook, or which I should say Alex presents in the textbook. And then afterwards, we do the traditional tutorial thing of solving for the equilibria, once students have already, in essence, found the equilibrium themselves. Now, a few weeks later, I posed a test question. And it was basically, I realized that not all of your students can handle this. University of Toronto, we have really good students. And we have a mandate to make sure that we set the bar pretty high as to who can go on because it's an entrance course for the business school. So this is a relatively tough question. Perfectly competitive market. Each firm has total cost, right? I give them the marginal cost, right? I ask them to calculate the price based on how many firms had entered, and then I ask them to find the long-run equilibrium. Right? Importantly, these are the types of questions that we always solve in our tutorials. Right? But importantly, at this time, right, the students actually, when solving the questions, right, had just participated as a driver and lived the fact that, as more drivers enter, right, this shifts out the supply, pushes out the demand. And so maybe this is going to help students answer this question when tested. Unsurprisingly, right, people who participated in the tutorial did a lot better on this question than people who didn't participate in this tutorial. And your first thing should be selection. People who show up at tutorials are different, right? And I agree. So what I've done is, right, I then look and I run a regression where I control for the marks earned on other questions, right? So now we're basically looking at two students who did just as well as each other on the rest of the exam, but one of them attended the tutorial where they played the game, the other didn't attend the tutorial, right? And what we see here is that participation in the experiment is both economically and statistically significant. On average, almost 1 mark higher was earned. I'd like to just finish off by looking back. Right? And the first thing, which I think is really important, right, is this was something that my TAs really loved, right? And right, they gave me really positive feedback. They thought this was a much better use of their time than just standing up at the board and solving problems as quickly as they can because their students were demanding that, right? Their students were much more engaged, right? At least as important, right, is that I think my TAs are learning new skills, or I know my TAs are learning new skills. They are learning how to run experiments in classrooms, but because MobLab enables iClicker-like functionality and enables reflection-like, right, they're also able to introduce these more participatory things in their tutorials, which, hopefully over the long run, we're adding to their human capital. Right, the other important thing which I'll highlight is, right, once again, these teaching assistants, none of them had ever run experiments in classrooms before. And so it was a learning experience for them, and they were successful at getting positive student outcomes from the student. And my favorite, I always poll my TAs at the end of the year for feedback from them. MobLab is such a big step up from traditional tutorials that even the worst game is better than generic problem solving. And I'm like, yeah, okay, that's cool. All right, and so just to finish up my students, right, predominantly but not universally positive comments in course evaluations. There were definitely some of them who were like, yes, I wanted TAs to solve more problems in tutorials, and I'm like, okay, whatever. But importantly, I have substituted in videos where we do problem solving for the problems that we're not doing in tutorials. So this is a classic case of, standing up there and solving a problem, right, is something that sucks whether you see your TA do it in real time or you watch a video for it, right? So, I don't think my students are missing out by having the video as opposed to the TA do it. And most importantly, there's at least some evidence of improved learning outcomes.